Hey, everybody. Here's Johnny. What's that from? What?
That's from The Shining.
The Shining.
Hey, guys, I'm hungry.
All right. Today we're doing 10.3 and 10.4. This is for the video, Math 35, lecture day 11. I'm going to say this is part A because I'll do 10.3 as part A. And 10.4 is part B. 10.3 is on quadratic formula. Ten point four is on equations in quadratic form. My advisor at grad school had a picture of that scene from The Shining with Jack Nicholson, where he's fucking his head looking through the window. He's got that on his door's window. So like when you walk up to his door to go look in, there's fucking just Jack Nicholson doing his creepy shit. All right, so 10.3. We actually derived this. We did this by hand. We did it doing completing the square on Thursday. This comes from ax squared plus bx plus c equals 0. These are actually the same equation. Which is why we can use the quadratic formula to find answers or values of x. Find solutions. To our equation. That's too bright. That's offensively bright. A little bit of a blue tint's better than a fucking overly bright. You can have too much white. Ask anybody that never goes out and gets some sun. That motherfucker pale as fuck. Too pale. Well, a white person that doesn't go out and get any sun. Everybody else has a nice coloring already. We're just the fucking, I don't know, bad skin ones, really. All right, so here's a little story to help you remember it. The negative boy was sad. He was such a square that he was undecided about attending or going to a radical party. He missed 4 awesome chicks. Missed, not messed, missed. The party was over at 2 a.m. didn't learn it growing up that way, but when I was a teacher, someone told me that's how they remember it, and I said, I like that. I don't know where they picked it up. But the negative boy is my negative b. He was such a square, b squared. He was undecided, which is the plus or minus. He missed a radical party. That should be two different things, radical, there we go. Missed 4 awesome chicks is minus 4 AC. And it was all over 2A. If it doesn't work for you, it doesn't work for you. If it does, you're welcome. You already knew it? Did anyone ever hear that? Something like that? No. I've only heard from one student and I liked it. It was cheese. Does anyone even call people square anymore? Even old people like me and Jackie don't use that phrase. That's just like, that's my mom's era, calling someone a square. That's like 50s and 60s shit. That part under the radical, the b squared minus 4ac, that is called the discriminant. It looks a hell of a lot like the word discriminate, but it is not. It ends in NT, not TE. But if you're trying to remember how to spell it, it's like the word discriminate, but with an NT instead of a TE. So, if b squared minus 4ac is greater than 0, what do you think that tells us about our answers?
They're positive.
It means that this is positive in here. What does that tell us about taking a square root of a positive number?
That's a whole number.
It might be a whole number, but at least it's a real number. We will have, and there will be 2 of them because of the plus or the minus. 2 real solutions. They may not be pretty. You might have the square root of a fucking 149 in there, and you're like, what the fuck? But just because it ain't pretty doesn't mean it's not, valid. What happens if it's less than 0? We have imaginary numbers, so that ends up being an imaginary, which means we have 2 complex solutions. Complex solutions are like A plus BI. So they got a real component and an imaginary component. Now what about b squared minus 4ac equals 0? What does that tell us? What happens to my radical? It goes away. Is the plus or minus relevant anymore? No. All we have left is x equals negative b over 2a. One real solution. So maybe I'll put lines between these to make it a little clearer. As they were a little close. So we're going to start off with giving you guys some practice on that. I'll call this A. We're going to end up solving these with the quadratic formula a little bit. X squared plus 8x plus 10 equals 0. B. 4x² plus 8x plus 8 equals 0. C 5u² plus 3u plus 6 equals 0. Find out what the solution is, the general shape is. Is there two real, is there two complex, or is there one imaginary? Not one imaginary, one real. So apply this stuff to this. And remember, you're coming from ax² plus bx plus c equals 0. So the letters come from the numbers in the problem. Bless you. You have dachshunds? My aunt used to have two dachshunds, a little fat chubby one that was a male, and a really slender one that was a female, and they were Maxie and Minnie, or Max and Min.
Oh.
She was not a math person, but it ended up having Max or math names. Max and Minnie. She was called Minnie. It's like Max and Mr. Minerva or some shit like that, but. And she got them as puppies, but she had no idea they were gonna grow. One was gonna be fucking chubby, the Max one. They're well named.
They're sisters, and my original one is Marley, and she's the runt. So she's pretty, like, she's skinnier. And then I have Brownie, which was my sister's, but then Brownie decided that she was my dog, and like that's my sister. She's the solid sausage.
That's the nice way to call it a little chunky one.
Mhm. It's not like she's like you can't. She's like thick, like I
Right.
don't know. She's just built differently. So
Dachshunds are the only breed that I ever want to put clothing on. And I want to put a little hot dog outfit on them. Cause they look like little wiener dogs. They got that hot dog shape. They're long and slender and narrow. Do you have a picture of that? No way, you dressed them up as hot dogs?
for Halloween.
Yeah,
Is it x equals negative b over 2a or is it over 2ac?
it's over 2A,
Just so.
cause it comes from. This. And if this part goes away,
Oh,
make sense? Give you one more minute, we'll do them together.
For my criminal justice class, we were doing a crime scene and they were obviously part of the crime.
That is so awesome. Oh my gosh, it's like a little, it's almost like a little pig.
Yeah, I know, she's like just,
She's around.
yeah, she's not like, you can't feel any like that,
Does her belly hit the ground when she walks?
no.
How Max was.
Let's see, and that's Marley.
Those are awesome.
See, they were, I told my teacher, yeah, I killed them because they kept walking in my crime scene.
Every other dog, I'm like, this is abusive, putting clothes on them. They don't want clothes, they don't want fucking shoes on them. But a wiener dog deserves a fucking hot dog bun. Let's make sure everyone's following along. I guess I didn't do an example, did I? So on this one, A is 1, B is 8, and C is 10. So B squared minus 4AC turns into 8 squared minus 4 times 1 times 10. Which is 64 minus 40, which is 24. That's greater than 0, so we have 2 real solutions. Everyone jiggy with that? What about the next one? So A, B, C. 8 squared minus 4 times 8. No, A is 4. And C is 8. This is 64 minus 16 times 8 is kind of like 2 times 8 times 8. So 2 times 64 is 128. This is negative 64. Which is less than 0. So 2 complex solutions. What about C? That's a shame. Because I really meant one of those to be a 0. I meant the middle one to be a 0. Huh. Again, 2 complex solutions. Now on B, if it had been 2x squared plus 8x plus 8. We would have had 8 squared minus 4 times 2 times 8. Which is 64 minus 64. And we would have had 1 solution. -8 over 2 times 2 is -2. Any questions so far? Alright. In fact, when we solve these, we're gonna do this version of B rather than that version of B. Alright. So solve. So A equals 1, B equals 8, C equals 10. I recommend putting parentheses everywhere. And then plugging in your shit. That way you don't fuck it up. Like, especially if you've got negative numbers, it's easy to fuck up the signs. If you don't use parentheses. So as a little reminder, we got negative B plus or minus square root of B squared minus 4AC all over 2A. My A's go right here, right there, and right there. My B's go in 2 spots. And C is a lonely duck. It gets 1 spot. So I've got -8 plus or minus. We calculated this earlier. This was 24. All over 2. So 24 is, we're looking to simplify, so I'm looking for square numbers. 24 is 4 times 6. Which means square root of 24 is square root of 4 times square root of 6. Which means this simplifies to 2 root 6. That radical does. And since 2 divides evenly into both numbers, we're going to do it. I'll split it up just to show you what's going on. We get -4 plus or minus the square root of 6 equals x. Ugly, but we can plug it in and verify it. The great thing about math that very few other subjects offer is that you can check your work after if you're willing to take the time to grind it out. I would probably do a calculator here because I do not want to plug in this into the square. I mean, it's doable, but it's meh. Very much a meh. And note, don't forget that means 2 solutions. -4 plus square root of 6, or x equals -4 minus square root of 6. These are called the exact answers. If you do calculator, you have approximate answers. Because like the decimal keeps going. It goes off the screen just because it stops showing decimals. Now this is really short. Like if you had like 0.625 or some shit like that, it just means it's simplified and you didn't see it. Very rarely does that happen. It shouldn't happen in something like this. All right, any questions on that one? Let's take a look at B. I'm gonna use the modified version, 2x squared plus 8x plus 8 equals 0. Now, what I did earlier is actually not the best choice. I jumped straight to the quadratic formula because I know it works. The quadratic formula will always give you an answer. You may not like it. It's not necessarily the fastest, and if you're sloppy with it, your notation is going to be inaccurate because you'll miss shit, you'll miss the signs. But it will give you the answers. But this is all divisible by 2. I can factor out a 2 here. And I get x squared plus 4x plus 4 equals 0. And so I could divide by 2 on both sides. And I get x squared plus 4x plus 4 equals 0. This is a much better choice. In fact, you don't need to do the quadratic formula here. This factors into easy numbers, but we're going to do the quadratic formula anyways. Negative b would be -4. Let me put my parentheses in. So this is 16 minus 16 inside there, 0. I just get -4 over 2, which is -2. And that's what we got earlier when we said it was the same thing as -b over 2a. When we did the shortcut approach. And finally, is there any questions on that one? Finally, had to ask that. Yeah, go ahead.
This is only under certain conditions though, where you could use the B into a thing.
Yeah, it was when the discriminant was 0.
Only when the discriminant is 0.
Yeah, because you'll see that that part actually does go to 0. This goes to 0. Not goes to 0, it is 0. I don't know that the discriminant thing is all that helpful, but it's something we're supposed to teach. It is good for checking things later on, like I got a fucked up answer, isn't even like in the right ballpark. And if you check that part real quick and you're like, I got imaginary numbers and the answer is supposed to be real, you fucked up. So you can do like little checks with it. The last one was the shitty one. So in this case, u equals -b, not x anymore because we're not using x. And my a is 5, my b is 3, my c is 6. So I'm gonna do my parentheses things. Usually the only time I get these wrong is when I get too fucking comfortable. And I just start skipping parentheses and trying to do the shit fast. And I fuck up a sign. Now, we didn't have any negative numbers here, but we will. So this is the, where we got, B is 3, that goes there and there. A is 5, goes there and there. And C is 6. That is 9 minus 120 or negative 111. All over 10. One 11 factors, but nothing does anything desirable. It's like 3 and 37, I think. But both of them are prime, so nothing to do there. The only thing we can do is we don't want to have a negative in the radical, so we're going to pull out the negative as I. And that equals U. It's
Question, I feel like with, whenever there's a 10 or 100 or 1,000, the body number. That's effectively a decimal. Right?
yeah, well, every fraction can be a decimal, but 10 powers of 10 on the bottom make it easy decimals. Like negative 3 over 10 is negative 0.3.
If you were trying to convert a decimal out of being a decimal, could you use that to work out? I feel like-
Yeah, you can always take a decimal and turn it into a fraction. We'll do that during break. I'll skim through a quick one during break. Well, not even a quick one. I'll do a shitty fraction, a shitty decimal. And we'll turn it into a fraction. All right. Let's, everyone ready? Does anyone want this a little longer? Hey, Lauren, we having fun yet?
Absolutely.
That's awesome. I'm really happy. If you like those, I think you're really gonna like this one.
I can't believe.
See, that type of attitude makes my day. All right. WTF? What do we do? We gotta clean this up, right? We can't do anything with it as is. You're right. So we should distribute. I'm gonna carry right down everything that I'm not changing. I'm gonna have it there. It's good practice. If you don't, you're gonna lose shit on your paper while you're doing it, and you're gonna solve the wrong shit. Always carry shit down, even if it's like you're like, no, I won't forget. Yes, you will. The phone goes off, a little text beep, fucking dog barks, phone rings. Fucking little brother runs in, or your child, or whatever. Something happens. And you come back and you look at it and you look at what you left, and since you were sloppy in the first place, you don't have it listed right. Now,
All of them on one side, well, everything needs to equal to 0.
yeah. The real reason why we want to make everything on one side, when we have a power greater than 1. That's the time to get everything on one side. If there's a cube, there's an x to the fourth, get it all on one side. If there's no square or anything higher, you just have a simple equation, you can get all the letters on one side, all the numbers on the other, and it's a quick solve. But let's do what Jackie said. We're gonna add z squared to both sides. And we're gonna subtract 3z from both sides. And I get a I got a z squared minus a 4z squared is negative 3z squared. Oh, this is ugly. And then I've got minus 3z plus 10. I'm guessing you probably have 3z squared plus 3z minus 10 equals 0. How are we gonna get to that? I don't like having a negative number in front, I really don't. So all I did is multiply by -1 on everything. Which just changes the sign. Now, I could have done it with this up here. It still would have worked just fine. This mic factor. I don't recognize anything right off the bat. And we're practicing quadratic formula anyways, so. Okay, let's do quadratic formula. A equals 3, B equals 3, C equals -10. So the B's go here. The A's go here. And C goes there. Now we got a negative number, so we gotta keep our eye out. Can't go too fast. I'm gonna take this a little slower in here. 3 squared is 9. I've got 4 times 3 is 12. Times -10 is -120. And I have a minus there, so I have minus -120. All over 6. And let's see. That simplifies to square root of 129, because that becomes a plus over 6. Let's see, 129 is 3 times 43. And those are both primes, so that doesn't actually get any planar. The only thing that we could really do to make it look cleaner is we could split it up a little bit. We could say -3 over 6 plus or minus square root of 129 over 6. Because then this simplifies. But I don't know that it's necessary. Let's see, square root of 121 is 11, so that's like maybe 11.1, 11.2. Divided by 6 is a little under 2. This is approximately -0.5 plus or minus. I'm guessing maybe 1.8. I don't know.
Question.
Yeah.
Why did we make it instead of -3z squared and -3z? Why did we make it +3 and turn the 10 negative?
Because I didn't want to deal with a negative number. If you did it,
You get a different answer.
you get the same answer.
Pretty sure
No, it's different.
it's different.
The -6 on the bottom.
But this is positive,
It's
and when you
gonna-
distribute the negative, you're gonna get the same. Let's do it.
You're gonna have a negative in the square root.
We'll do it right now. So. This should have been a Z. That's where I gasped. These were all Z's. I fucked that up. We're gonna go back and make sure that this works. So A is -3, B is -3, and C is 10. -4. So negative negative becomes positive. -3 squared is 9.
Your first beat,
You know, it's positive 3, but
-3.
Which I wrote as I wrote 6. My bad. I'm like, what are you guys talking, why are we focused on the negative? I know I did the negative, right? Alright, we've got -4 times -3 times 10 is plus 120. We do not have a negative inside.
I had a negative, or I had, my A was 3, I messed up on that one, not -3.
It was worth seeing, now I'm glad you brought it up. So like, this is this. And it looks different than that. But if I move the negative up to the top. Because we can, it hits everything in there. The 3 becomes negative. The sign's kind of like the plus version became the minus version, and the minus version became the plus version. But since we have both, it doesn't matter. And so that is -3 plus or minus square root of 129/6. So it's the same both ways.
So the plus or minus sign getting mirrored, does that have like any effect on anything else?
What do you mean?
Like, you know how you drew the plus or minus sign like upside down, does that
No.
mean anything?
No. The only reason I showed it was to show that hitting that with a negative turns it into that. And hitting that one with a negative turns it into that. I would never have even written this. I did it for teaching purposes. If I'm doing so like a complicated problem, I might actually write down the negative positive because I know it means the same thing. But it helps me track my work later on and go, what did I do? And I can see it there. So we wanted decimal answers to this. We got like a minute left before break time. I've got -1/2 plus square root of 129/6. Or -1/2 minus square root of 129/6. Let's just do that 129/6. Okay, once in the calculator. Let's work smarter and not harder. Oh, I said 1.8, that's about 1.9. So square root of 129/6 is approximately 1.9. So -0.5 plus 1.9 is going to be 1.4 approximately. That's what the wavy line means. It means it's not equal, but it's close to equal. And if I do -0.5 minus 1.9, I'm going to get approximately -2.4. And those have their uses, like when we do graphing of this stuff. I can find negative 1.4 or negative 2.4 and 1.4 on a graph. I'm gonna have a really hard time finding square root of 129 over 6. I'm gonna show one other thing before I go to video real quick, or pause. It's a short thing. Sometimes they might have you do it where you don't substitute stuff in, you don't know where they are. So a generic formula for position with falling or height is S. S equals V naught T plus GT squared over 2. That should be plus, that should be minus. Gravity goes downward. If you wanted to, you could solve for T here. Like, when is S 0? Or when is the height 0? That's not what I want, that's not what it's doing. Yeah, S is starting height. So when is height 0? I would move the S over to the other side. I'm going to change the order to this real quick. And now T is my variable. So A in this case is negative G over 2. B is V naught, which is initial velocity. And C is negative S, which is starting height. So we could go ahead and plug it all in. And it's not going to be a pretty formula. The negative, there's one negative after you multiply that out, but 4 and the 2 simplify to 2. 2GS over negative G. Which means I can move the negative up top and have V naught. We did stuff like this when we like y equals mx plus b. When we saw like we can solve stuff and leave the letters in there. These are called literal equations. I can tell you there's not going to be one on the test. But knowing how to work with literal equations is helpful. Like that way, if you need to solve a particular equation that has a lot of variables and you got to do it a bunch, and if you can solve it where everything is something like this, you can put this shit in a computer and a computer will grind that shit really, really fast. Excel will fucking kick that shit in the teeth. All right, let's take like a 6 or 7 minute break. I will make a second video for 10.4.